Welcome to the Fuel Pulse Show podcast, where we talk about all things fuel for all kinds of people. I am your host, Eric Bjornstad, and today I'll be your guide through the ever-changing world of fuel. At the Fuel Pulse Show podcast, we talk about all the things surrounding all the different kinds of fuel that we use professionally and at home. And then we also talk about lots of things concerning the stuff that uses that fuel. Again, both at work and at home, which means the Fuel Pulse Show podcast is really intended for everyone. And so what are we going to talk about today? Well, last time we talked about hot weather and its effects on stored fuel. Though really, we spent most of the time talking about why we think it's going to be hot for a while and why the analysts and the scientists insist that what we're seeing right now is, shall we say, a period of some historically hot weather. But that is never where we intended to stop, because ultimately, while all that's nice to know, we want to know how that fact is going to affect our stored fuel. And we want to know what steps that we can or should take to protect that fuel investment. And so, here we are with part 2 of our discussion, where we'll get into the practical implications of living through a climate that's getting hotter than it ever has before. So with that, let's get started. Let's start with the accepted premise that it is hot right now and it's going to be hot for a while. Now, while we are used to, from a fuel standpoint, while we're used to preparing for the cold, especially if you're one of those folks that lives up north, you're prepared every year knowing that you have to do something or that you're going to have to do something for your fuel to prevent cold weather problems from infringing on your business. You know that. So we're used to thinking about that with respect to the cold, but we're not used to thinking about having to do anything to prepare for how the heat is going to affect our stored fuel. But if you think about it, heat affects fuel in a larger or broader number of bad ways than cold weather does. And maybe that's why people in colder climates have a more specific idea of what they need to do in the winter, along with the determination to actually do it, because it's a more simple problem solution scenario. Cold weather problems in diesel fuel are fuel gelling. That's about it. Simple solution is add anti-gel treatment to prevent that gelling. Easy. Now, maybe people don't ask the same kinds of questions for the hot weather effects because to them, the answer may not be so straightforward. But heat affects fuels in more different and in more indirect ways than the cold does. If fuel gets cold, it might gel and shut down your equipment. But for heat, it's not usually a case of what happens if the fuel gets too hot. No, it's really what happens if the fuel is exposed to hot temperatures for sustained periods of time. So, exposure to elevated temperatures, let's say this, exposure of the fuel to elevated temperatures can significantly affect stored fuel in several ways. And so we're going to talk about those, and we're going to start with the simple ones. Let's knock those ones off the list first. Making fuel hotter makes it evaporate faster and changes its composition. Okay, so evaporates faster. We might term it as increased evaporation rate. So higher temperatures can increase the rate of evaporation of fuel, especially for the more volatile components in that fuel. And this, if it goes on long enough, leads to changes in the composition of the fuel, which can affect its performance and its efficiency when it's used. Having said that, let's dig into this a little more. Now, we have to start by acknowledging, this may be something we already know already, but for those of us who have forgotten, we start by knowing that both, when it comes to fuel, both gasoline and diesel fuel, they're really mixtures or blends of a bunch of different kinds of hydrocarbons. Some of those hydrocarbons are lighter weight, smaller molecules. Some of those hydrocarbons are a little bit heavier, bigger. And All of these fuels, diesel fuel and gasoline, are blends of all those together. So when fuel gets hot, the evaporation rate of the fuel speeds up. And we know this is not news to any of us. We know this is intuitively true by watching other things, like the fact that water will dry or evaporate faster when it's hotter than when it's colder. Easy. But if fuel, let's say if diesel fuel is really a blend of light components and heavier hydrocarbon components, and the fuel evaporates faster in hot temperatures, then what does that say about the evaporation rate of those lighter and heavier components? Do they all evaporate equally at the same rate? The answer is no, they do not, and that is important. The lighter components of the fuel will always evaporate more readily. Now, since these lighter components of the fuel evaporate more quickly from the fuel than the heavier ones, then what happens as the fuel is exposed to higher temperatures over a longer period of time is that those lighter components of the fuel will evaporate out of that fuel, and that changes the overall composition of the fuel. The overall composition of the fuel can shift. And if this goes far enough, then this change can lead to certain things happening in the fuel. For example, in gasoline, it can lower its octane rating, which, if you know anything about using gasoline that doesn't have enough octane, contributes to things like engine knock, reduced engine efficiency. In diesel fuels, if the lighter components in that diesel fuel evaporate out, that can change the composition of diesel fuel. And that can do things like it can change the fuel's viscosity, potentially leading to problems like harder starts, less efficient combustion. Okay, so that's number one. Second problem that exposure to hot weather over a period of time can lead to is decreased fuel efficiency. Now remember, lighter and heavier fuel components, again, we already established that fuels are blends of lighter and heavier things. And they're blended in there because each one of them does a different thing or contributes in a different way to the fuel's properties. Okay? The lighter components in, say, a diesel fuel mix, those tend to be associated with helping the fuel to ignite, especially in cold weather. If those lighter components evaporate away and they're not there anymore, what happens to how that fuel performs? As the lighter components that contribute to easier ignition and stable combustion, as those things evaporate, aren't there anymore, the remaining fuel can become less effective. This can lead to things like lower mileage and decreased performance, and nobody wants that. Increased evaporation of the fuel because of hot weather does not lead to good things happening in that fuel. And those are the relatively simple, short-term effects that prolonged heat exposure brings. But prolonged exposure to high temperatures also linked to some other things. It's linked to chemical changes in the fuel that slowly but surely, if nothing's done about them, will result in problems developing down the road. So let's consider three factors in this case. First, oxidation and instability. As fuel is stored, any fuel that's stored always has chemical reactions happening in that fuel pretty much all the time. Those kind of chemical reactions, though, tend to happen faster and more often in hotter situations. And the reason that is because there's more heat energy present to drive those reactions. So you will get more oxidation reactions, you will get more hydrolysis reactions, and you will get more what they call polymerization reactions. That's when you have two shorter molecules that react together and they join and they form one bigger molecule, and then it goes off and it reacts with another molecule. They join together and they get bigger and bigger and bigger, and they form these chains called polymers. More of these reactions happen in hotter weather because there's more energy to drive them. And all of this, the eventual result of all of this is that the chemical structure of the fuel gets changed. And the result to that fuel is its quality and effectiveness is diminished. The oxidation reactions will form things like gums and varnishes. The fuel may darken. Anytime you see something like that, it's because these chemical reactions have happened in the fuel. And so that is the first one. Prolonged exposure to high heat over time reduces the fuel's stability and increases the degradation of the fuel's essential quality. Now, that's one thing. Second thing is temperature has a direct effect on how water plays with the fuel. Now, there are two things here that are well known about petroleum fuels. The first thing is that all fuels contain a certain amount of water, and it's in there in one or more of three forms. There's free water, which is the kind that you find in the storage tank. It forms a layer at the bottom of a storage tank because water is heavier than fuel. That's free water, when you have a layer of water at the bottom of the storage tank. Then there's suspended water, where droplets of water hang in the fuel without dropping out. They're kind of suspended in there. That's when you get a fuel water emulsion. That's suspended water, the second form. And then there's the third form, which is dissolved water. And because it's dissolved, it's water that you can't see, but it's still in there. Now, all fuel in the real world has a certain amount of dissolved water in it at a minimum. But how much water it has, how much dissolved water it has, depends on the temperature. Because when fuel is warmer, its capacity to hold dissolved water increases. It's known that ultra-low sulfur diesel fuel theoretically can hold up to about 200 ppm dissolved water at hotter temperatures. But when the temperatures are colder, when the temperature of that fuel decreases, the amount of water, dissolved water, that it can hold also decreases. If you lower the temperature of ultra-low sulfur diesel to, let's say, 40 degrees, the amount of dissolved water it can hold actually will drop from 200 ppm down to below like 80 ppm. So that can be a substantial difference. Now, think about, for your situation, think about the fuel in your storage tank in the summer. Because it's the summer, it's hot out there. You've also likely got humidity in the air. And so that fuel's being exposed to high heat over a long period of time. And because the fuel's hotter, it has an increased ability to dissolve more of that water vapor, more of that humidity, and hold it as dissolved water. But then, when day turns into night, what happens? Well, temperature drops, the fuel naturally cools down. So what happens to all that extra water that it dissolved during the day? Because the fuel is cooler, it has less of an ability to hold dissolved water, and so that extra water is going to come out of the fuel because it can't hold it anymore. It's going to come out as free water, and it's going to drop down to the bottom of your storage tank. It's going to build up as a free water layer. Now, that's diesel fuel. Ethanol blended gasoline is a whole nother animal, because the water dissolving temperature principle still holds, but the extra problem that happens with ethanol blend gasoline is that when you get that extra water coming out because of the temperature change, it's not just going down to the bottom of the tank, it actually increases your chances of phase separation happening in that fuel. And phase separated gasoline is something that nobody likes. So hotter weather means your fuel is going to go unstable faster, what we said a minute ago, and it's going to develop water problems faster. The third issue that prolonged heat makes your fuel more prone to is something that relates to that excess water problem. And we're talking about developing microbial contamination. When you're talking about heat and microbe problems in stored fuel, heat is linked to microbe problems, not just because of heat's linked to the water, but also because of the simple fact that a number of the microbial species that tend to be commonly found in fuel storage tank situations and environments, they just simply grow better in warmer temperatures. So that's true, but the whole water thing is really the bigger part of the picture here. Microbes need water around to grow and to thrive and multiply and do what they do. Now, microbes will prefer that water be in free water form. Ideally, what they'd like is for there to be a nice healthy layer of water, a nice healthy water phase at the bottom of the tank. And so they'll live near the surface of the water phase, near what they call the interface. the separation between the fuel phase on top, the fuel layer on top, and the water phase at the bottom. Wherever those two meet, that's the interface. And so the microbes like to live near that interface because what it does, it gives them an opportunity to move in between the two layers, the two phases, and pull what they need from both of them. So that's what they do. They live near the interface, they pull what they need from each one, they form colonies, they produce biomass and they live in that, and they generally multiply and they do what they do. Ideally, if there's a free water phase around. Now, having said that, what we're not saying is that if there's no free water, microbes can't grow. That is actually a misconception. But it is easier for microbes to grow if they do have a free water phase. And remember what we just said a minute ago. Prolonged exposure to hotter temperatures in the environment means you're inherently going to get a greater water buildup in your storage tank. And that leads to a greater chance of microbial contamination developing more often. So, heat affects fuel by affecting its evaporation, changing the fuel's composition, accelerating fuel instability, increasing water buildup in the fuel, and by making microbial contamination markedly easier to develop. So now that we know these issues are more likely to happen in the hot weather, we can now move on to planning what we're going to do about them. In this case, the best practice recommendations to head off these heat-related problems are actually relatively simple. Here's what we would recommend for you if you have stored fuel in hot weather to help head off some of these hot weather problems for you. Okay, recommendation number one is check for water regularly in your system. Now, since you know that water buildup happens faster in hot weather, the object then is to simply check your stored fuel regularly for that water buildup. That's really the first step in any good fuel maintenance program at any time of the year, really, not just in the summer. And what you're doing is you're checking for the presence of a water phase in your tank. To do that, you want to use a tank stick and some water paste. You put some water paste on the bottom, let's say a couple inches layer on the bottom of that tank stick, and you drop it down to the bottom of the tank. If there's any water down there, it's wherever that water contacts, wherever that water phase comes up to on that stick, it's going to change the color of that water paste. And so when you see how much color change there is, that basically tells you not just if there is a free water phase down there, but how big or how deep it is. So if you find water, does that mean you actually have to do anything? Some people say that if you find a water phase, you don't really have to worry about it until the water phase is more than X inches in depth, 1 inch or 2 inches. Our recommendation is a little bit stricter than that. What we would recommend is that as soon as you can detect the water, you want to try and drain that water and get rid of it, because microbes don't need a minimum amount of water to grow. It's not like if you have a 1/4 inch water phase, the microbes are like, we're going to wait for a better offer. No, they can grow in virtually any amount of water. So as soon as you detect water, you're going to want to get rid of it. And you definitely want to do this because not only do microbes not need very much water, but the ultra-low sulfur diesel fuel itself is inherently much less resistant to microbial growth than the diesel fuels of the past. And that's for a number of reasons. Biggest one we think is because of the regulations that came out of the Clean Air Act. Not only did they take the sulfur out, which is why it's ultra-low sulfur diesel, but it also changed the aromatic content, placed a stricter limit on the aromatic content, because aromatic hydrocarbon molecules, when they're burned, they produce, shall we say, air pollutants that aren't very good for urban air quality. So there's fewer of those in there, and that makes the fuel something that microbes find much easier to grow in. We'll put it that way. If you can detect a water phase with your paste, you should do your best to get rid of it. Now, how you do that depends on the configuration of your tank and your situation. If you can drain it off easily, you would definitely want to do that. If you don't really have that option, you may have to consult with somebody else to get rid of that. Point is, you want to get rid of that water as soon as you detect it. So, big step number 1, check your stored fuel for water regularly. Step number 2 is treat the fuel for stability as early in the summer as possible. We've already said, hot weather speeds up fuel degradation. The way to slow fuel degradation down or to stop fuel degradation, since you can't do anything about the hot weather, you can't do anything about that. So what you can do is put something in the fuel that stops those chemical reactions from proceeding. And that thing is going to be a fuel stabilizer package. Now, the best practice is to add stabilizer to the fuel at some point at the beginning of summer. So it's in there when the hot weather wants to drive all these reactions. The stabilizer's already in there to stop them from happening. Now, if you're listening to this and it's later in the summer, maybe you're thinking, well, it's too late for me. Summer's almost over and I didn't do that. Well, you're not out of luck though, because when we say treat at the beginning of summer, that's the ideal. But if you miss that, that doesn't mean there's nothing that you can do about it. Your next option is really to get stabilizer into your fuel as soon as possible if you haven't done so already. Doesn't matter what time of year it is. Either way, whenever you do treat, then whatever's needed to stop those reactions that destabilize the fuel is going to be already present in the fuel when those reactions want to start up. And that's really the best thing that you can do to keep your fuel stable and to protect its essential qualities for when you need to use it. Third thing is you need to test for microbial growth. Okay, let's talk about that. Now remember, we said one of the big heat-related problems was the microbial growth that often goes along with that water buildup problem. If there's one thing you don't want in your stored fuel system, it's a microbial contamination issue. So, if you don't want it, what are you going to do to prevent it? You have a couple of options, but any of the options worth considering all start with the understanding that microbial contamination is killed by adding biocide to the contaminated fuel. It is not killed, it is not solved by removing water, contrary to what some in the industry might want to say. It simply does not work that way. It especially doesn't help remove an existing microbial contamination situation that's already taken root. We did say that microbes need water to grow and thrive, but that's different from then saying that if you take the water away, the microbes that are already there are going to die. That is not the way this works. The only thing that will cause them to die and that will solve this microbial contamination situation you might have is killing them by adding a chemical biocide into your system. So, if you understand that, do you treat the situation, the microbial situation, like you do stability? And let's say you might consider proactively putting biocide in at the start of the summer. Remember we said for stability, put stability in at the start of summer so it's in there. Maybe you want to treat biocide the same way. Now, for a while, that kind of thing was actually considered acceptable practice. What they would do, what they termed it as was they called it prophylactic treatment. And the trick was that you would put lower amounts of biocide. Typically, it was about half of what they call a shock dose, and they would call this a maintenance dose. So you would put lower maintenance dosages of biocide in the fuel, and you do it at regular intervals, whether you thought you had a microbe problem or not. And doing that, the rationale went, was supposed to kill and wipe out microbial contamination before it even got started. But that approach is not the one that we would recommend. It's not likely what we would recommend. We think the best thing for you to do from a fuel management standpoint if we're talking about what to do to prevent hot weather problems, our recommendation in this sense is you want to have biocide around to use, but you don't need to use it prophylactically. You want to use it to kill the microbial contamination as needed. But as needed implies that you need to know what that is. In order to do that, you have to know when you need it, right? And that means microbial testing. So let's talk about that. There are a number of different tests, what we call market-ready tests. A number of different kinds of tests that you can use that are available for you to use to detect microbial contamination. But not all of these kinds of tests are created equal. So how do you know what's good? To start with, you need a test method that will give you more specific results than a simple pass-fail, which is what some of those do. If something's going to say yes, no, one question you immediately ask is, how do you define yes, no? What triggers a yes versus a no? Now, some microbe tests, the ones that I'm primarily talking about for this particular thing, some microbe tests are simply different versions of a culture test. A culture test is really the oldest kind of microbial test in the book. And what it does, it requires you to inoculate some kind of growth medium, and then you wait. You incubate it and you wait for microbes to grow. And if microbes grow, then you've got microbes in your tank. And if they don't grow, then you don't. However, it's not that simple, because many of these kinds of culture tests are pretty hard to interpret, and they're also overly subject to outside influences like cross-contamination. They also have what I would call a term that I would say is they have a high level of detection. What that means is that they're not very sensitive. That means that you need to have a lot of microbes present in order for them to show up in your results. And that leaves those kinds of tests overly prone to excessive false negative readings. False negative reading in this kind of situation would be where you don't think you have microbes because the microbes didn't show up in the culture test. But in actual reality, you actually do. They just didn't show up. It was a false negative. The test falsely and incorrectly showed you that you have negative microbes. You have no microbes, when in fact you actually do. That's a problem, because then you're not taking the action that you need to. So what you really need, you don't need a culture test. What you need is a test methodology that's going to give you what we would term a quantifiable result. Quantifiable results are preferable to the yes, no, or the low, medium, high results that you get with some, because a quantifiable result, it's a number. It gives you more of an exact number. And that's really valuable, not only for you being able to tell if you've exceeded a threshold for action, but it also helps you because what you can do is, if you do this kind of microbial testing over time, you're going to build up a history relative to your specific tank. And you're going to be able to see how your microbial levels change specifically over time. And that's really going to be useful for you in the future when you're having to determine if you need to take action. So, when we say quantifiable results, the one that we would recommend is ATP Bifiltration. That's the test methodology, the name of the test methodology. And one of the big advantages of ATP Bifiltration is that it gives you this kind of exact, specific result. Doesn't give you a pass-fail, doesn't give you a low, medium, high result. It gives you a number that relates to the number of microbes in your system. And that's useful. Doing ATP bifiltration methodology requires you to have a specialized piece of equipment called an illuminameter. Now, if we had to name a downside for ATP bifiltration, it's that the startup costs can be a little higher, because a specialized piece of equipment like a illuminameter is not cheap. They might cost, I don't know, $5,000–$6,000. Now, for some companies, that is, chump change for them. But we're not going to assume it's chump change for you. And it's not for many other kinds of businesses either. So if you don't have the funds to buy a luminometer, what do? Well, there's an alternative, and that is that there are places out there, they offer sample submission kits. And what those do is they give you all the materials that you need to pull a sample out of your tank, package it up. They cover the postage to ship it to a specific lab that does this testing. The test is done at the lab, and you get the results back. And it's a fairly reasonable cost. So there are some businesses that elect to do it that way. Point is, though, is that for this third best practice recommendation, you need to do microbial testing so that you can tell if you need to take action on any potential microbial contamination issues. Now, when should you do this testing? The best practice is, ideally, test your fuel twice. Test it at the beginning of summer to establish that you don't have a problem, and then test it again later, like maybe towards the end of summer, to make sure that you see if any of that has changed. If the microbial levels on the second test come back elevated, you will now be in a position to know you need to treat it with biocide. But doing it this way not only helps you head off microbial problems that might develop in the hot weather, but also has the advantage of, if your results come back clean, you're not spending money and wasting resources on taking action that you really didn't have to. And for anyone who's run a business, you know that that's a valuable thing to say too, right? So, to summarize all this, prolonged exposure to hot weather and stored fuel can accelerate certain kinds of problems in that stored fuel. Some of those problems you can't do that much about. Like, you can't do that much about excess evaporation. You don't have the ability to change the weather or to cool your tanks down in that way. But the other kinds of problems are ones that do have proactive steps that you can take to mitigate their future effects. It just takes a little bit of proactive planning, and it takes a commitment to recognize these problems, to acknowledge their potential severity when you see them, and then have the commitment to take the simple steps, in most cases they're simple steps, to reduce the chances of those problems happening to your stored fuel supply. And so that is what we would recommend for you if you have stored fuel in the summer. Our recommendations to head off hot weather problems in your stored fuel. That's going to do it for today's episode of the Fuel Bill Show podcast. And thank you very much for joining us. Again, feel free to subscribe if you haven't already. Subscribe to the podcast, whether it's at iTunes, Stitcher, wherever you get your podcast from. Feel free to subscribe. Also, if you haven't done already, we really would appreciate if you could leave us a rating, because that really does help other people find us, and we really would appreciate that. So, till next time, thank you for joining me today, and I'll see you next time for the next episode of the Fuel Pulse Show podcast.